Well, good morning, everybody. Thank you for joining us for today's webinar where we're introducing Tecplot 360 2022 R1. We're going to go over what's new in the product today. We're also going to introduce a companion release with this one, which is the work that we've been doing on higher order element support that we're introducing as a technology preview, which is actually a separate download, and we'll go through all the details on that. Presenters today, myself, Scott Fowler. I'm the product manager of Tecplot 360, PyTecplot, Tecplot Focus, and all the other tools that you receive from Tecplot Incorporated. I'm joined today by Scott Imlay, our advisory software engineer, who's really the brain behind the higher order element work, and we're excited to have him on the line today as well.
Good morning, everyone.
So we do ask that you participate in the webinar. Also joining us today from the Tecplot team is Brandon Markham, who is in the product management group along with me. His name may sound familiar as he was also in our tech support group, so highly technical mind and can answer any questions that you guys have during the webinar. If we can't get to your question during the webinar, we will also have time at the end to go through questions and answers, and any questions that you have, whether they're related to the content that we have today or just, hey, I wish I knew something else about Tecplot 360 or PyTecplot, feel free to ask us. Okay, so just a brief introduction to who Tecplot is. We were founded in 1981 by a couple of Boeing engineers who were writing CFD codes, and they needed a way to visualize their results because there really wasn't a good post-processor on the market at that time. And they hired a developer who is actually still at Tecplot today to write the Tecplot product, and it's clearly evolved over the years. And our development team has grown, as has our user base. We estimate that we have about 47,000 users worldwide. Tecplot 360 is really known as being one of the most complete desktop solutions with its integrated XY, 2D, 3D plotting, beautiful 3D plot like you see here, but also line plots to help you get the quantifiable information out of your data. And we're really dedicated to saving engineers time. The way we do that is working on new technologies. On the Tecplot 360 side, we've really focused the last number of years on this SCPLT file format, which is a unique file format in the market in that it only has to load the cells needed to generate the plot. So you're loading less data off disk to generate slices and isosurfaces, and thereby using less RAM, reading less data, so speeding up your post-processing. We also developed Tecplot Chorus, which is a tool used for understanding ensembles of data. So we have people using this for developing and visualizing aerodynamic databases or doing optimizations, multidisciplinary optimization, those sort of tasks. So very useful tool that comes with your license of Tecplot 360. And then finally, automation. We're producing so much data today with the additional HPC resources that we have that you really can't process all that data sitting, pointing, and clicking. So you need a good way to automate. Tecplot 360 has two ways to do automation. One is through our legacy macro language, which I say legacy, that doesn't mean it's going away. It is under continual development, but most new features are really going to be going into our Python API. And Python being really a glue layer for engineering, being able to tie together multiple products. So a really interesting and useful API there. Okay, let's get into the meat of today's webinar, which is what's new in 360 2022 R1. We're going to introduce LaTeX support in Contour Legends. We'll talk about data loader updates, a performance improvement to our TechIO library. If you're not familiar with TechIO, that is a linkable library that allows you to write Tecplot data file formats, ASCII, SYSL, and PLT formats. We're going to talk about platform updates. So if any of you on the line are in the IT group or have an interface with your IT group, you may want to pay attention to that bit and let them know about the new platform requirements. And then finally, we're going to introduce the higher order element technology preview, which again is a separate download on our website. So in our previous release, 2021 R2, we introduced this new capability to define the text that you want to use on the contour legend. Previous releases, in order to have a custom piece of text up there, you had to actually change your variable name, which was a bit of an annoyance. This new GUI makes it easier. And we heard feedback from users saying, hey, that's great that I can put custom text in there. I really want to put LaTeX text on there. So we've had LaTeX in the product support for a while now. So we took the time to, add that to the contour legend dialog as well. So you'll see on the contour legend dialog, there's now a third option under that header text field called Use LaTeX, and you can put in your LaTeX string there. Now, just a couple of notes about how Tecplot 360 manages LaTeX. It does require that you have a separate LaTeX install on your machine. So Tecplot 360 does not have a LaTeX engine built into it. It's reliant on you having one installed. Custom configuration can be done via a file included with Tecplot 360 called tecplotlatex.mcr. So that's where you can define which packages are available, which LaTeX packages are available when using it within Tecplot 360. And that Tecplot LaTeX MCR file, we have designed that and tested it with MikTeX and TeXlive. If you're using another LaTeX package, you may have to get into that file and make some alterations. And please feel free to reach out to us for some help if you need it there. Then just some additional resources. We've did a webinar and a blog on LaTeX fonts back in 2017, so you can see some great information at the link that you see there on the screen. And then also we have some really good resources in our user's manual. So just search for LaTeX in the Tecplot 360 user's manual. Okay, data loader updates in this release. So probably the biggest one is ANSYS Fluent 2022 R1. With their release, they made some slight changes to the CFF file format. So that's their HDF5 based file format, in which we were not able to load those files into Tecplot 360. So we've partnered with ANSYS, and they've been very gracious in supplying to us a library that we use for reading their files. We got an update to that library, and we are now able to read the CFF file format from ANSYS Fluent 2022 R1. Just a couple of notes about the ANSYS Fluent file formats. So their legacy case and dat format, you can still read that into Tecplot 360. You can still write that from ANSYS Fluent. But ANSYS has done a lot of work to improve the performance of writing data. And the CFF format, which is based on HDF5, is smaller on disk, and it's actually faster for Tecplot 360 to load. You can see the numbers there. If you're still using the legacy format, I understand that maybe you have some other post-processing routines that you're using, but I'd encourage you to try that HDF5 format. I think you'll see good benefit from it. ANSYS also reports that it's faster to write in addition to that smaller on disk. So a pretty nice addition there. Abacus 2022, not a lot to say there, but we have updated our libraries to support the Abacus 2022 file format. We have an HDF5 loader. So HDF5, let me explain here a little bit. So not all HDF5 files are created equally. A lot of people say, hey, Scott, can you just create an HDF5 loader? And the answer is really no, we can't, because HDF5 is, think of it as just kind of a database. It's a data container, and everybody's HDF5 files can be organized very differently, right? ANSYS Fluent, their data files are formatted differently than, say, Converge writes out post.h5 files, and the organization of those files is very, very different. So we effectively need a separate data loader for every HDF5 file format. Well, this generic one is designed for loading structured data sets. And with this, our generic HDF5 loader, we've made it about 6 times faster. So with a comparison test of a data set that we received from a customer with 120 million nodes and 6 scalars, one of the options in the loader is to create implicit grid variables if grid variables are not defined in the file. We saw that speed up was about 6x with this performance improvement, and this data file that came from the customer did have grid variables in the file, and when we loaded those directly, we saw a speed up of about 4.7 times. So if you are using that loader, it's a great opportunity to upgrade and get some performance improvements. Then the final major update is the Nsight loader. We've seen some codes are writing Nsight files with spaces in the file names, and we just never seen that before, so our loader didn't support it, and now it does. So if you have spaces and quotes in the Nsight.case file or spaces in your variable files that are sitting on disk, Tecplot 360 will now be able to load those Nsight files without problem. Okay, Tech.io, again, Tech.io is a library that we provide to write Tecplot data file format, PLT, sizzle format. You can also write ASCII with it. And what I say here is don't forget to flush. So when writing Tecplot data files to the sizzle file format, Tecplot, the Tech.io library, needs to hold that data in RAM. This is an interesting issue with our SCPLT file format. Is in order to get the drastic speed ups with the sizzle file format, we hold that data in RAM, and then as we write it out to disk, we subdivide the volume cells into what we call subzones. That way, when we read that data back in, we only need to read the subzones that are required for the plot that you're making. So thereby, we're reading less data. So the Tech.io library, again, holds that data in RAM until you're ready to write it to disk. And early on in the development, we said, well, gosh, we're holding too much data in RAM. So we added this new function called TechFlush, which will do that subzone partitioning, write the data to disk, and then when you finally call TechEnd, which you can see the last line here, that's going to reassemble all these intermediate files into a single file. Well, we found a bug in the Windows version of Tech.io where the RAM wasn't getting properly released. So we've updated the Windows version of this library to do that, and now you'll see much less RAM use and better performance out of the Tech.io library when writing sizzle files. So again, the cadence for calling TechFlush, generally the best starting point is if you're writing a transient file, then call it at the end of each time step, and that's a good spot to make that call. Okay, platform support changes. Really, this is just a duplication of what we have on our website. So we're supporting Windows 10 and 11, Mac 10, 15, and newer Red Hat 7 and 8. CentOS 7, you notice that CentOS 8 has been dropped because that's also been, that platform is no longer supported by CentOS. So at Tecplot, our platform support policy is we don't support platforms that are not supported by their manufacturers. So that's the major reason why we dropped that one. Just a note that it looks like Rocky Linux is positioning itself to be the replacement for CentOS, and we're evaluating supporting that in our next release. Ubuntu, we support 18, 20, and 22, and then SUSE Linux Enterprise Desktop 15. Now, we do have a number of customers who are running SUSE Linux Enterprise Server 12, and they have good support with it. We've seen people run Tecplot 360 on Amazon Linux as well. So these are the platforms that we support and officially or test on and officially support. Tecplot 360 may work on other platforms as well, but it's going to be more difficult for us to support you on those. Just a note on Python. Again, our policy for Python versions is we support the current release of Python and the 2 previous releases. So currently that's 3.8, 3.9, 3.10. And Tecplot 360 and PyTecplot have worked with earlier releases of Python 3 in the past. I think we've seen it work all the way down to 3.4. Now that said, there's been an update to one of the third-party components that PyTecplot is reliant on when you're using Tecplot in what we call connected mode. So that's when you're using a Python script to drive the 360 user interface. We do a socket communication between Python and 360 to do that driving, and that uses this library called protobufers. And the current version of protobufers has a hard requirement of Python 3.7 or newer. So you may still be able to use Tecplot with earlier versions of Python without using protobufers or using an older version of protobufers. But again, those versions are outside of our official support policy, so we're not going to be able to effectively support you with those earlier versions. So please talk to your IT group and ask them to update your version of Python. Okay, higher order elements. So this is really what the bulk of our dev team has been working on this year, and it's not quite ready for full production release, which is why it's not rolled into the 2022 R1 release, but we wanted to put it out there and get feedback on it. So we've seen a lot of academic and government codes researching higher order elements, and we realized that there's a bit of a chicken or egg problem here. A lot of people want to use higher order elements, but they don't have good post-processing for looking at the results of higher order elements. Or if they're doing higher order elements, they're doing a subdivision of their higher order elements into smaller linear cells, but then that makes their post-processing files huge and cumbersome to deal with. So we've seen some movement in the industry. Pointwise did a great job in adding higher order elements to the grid generation. Now we're seeing these academic and government codes adding higher order elements to the solvers. We've seen there are a couple of post processors out there that do support higher order elements, but we kept hearing from our user base, we want to use higher order elements. So here we are, we've made the effort. So if any of you on the line have higher order element codes that you're using or thinking about, here's what we have available today in this technology preview. We can support Lagrangian elements up to P3, so P2, P3 elements. And Scott Imlay, this technology preview, we're actually short by 2 elements. Can you remind me which 2 elements on P3 that we don't have support for yet?
Sure. Yeah, the 2 that we don't yet support are Prism and Pyramid. I'm sorry, Prism and Hex.
Right.
So that'd be the hex, the brick basically, for cubic elements.
But both of those are under active development and getting close to complete, right? Okay. So right now we can only load data from CGNS files that have higher order elements. We do have Python APIs and C APIs for pushing data into Tecplot. So if you do have a solver that is writing higher order elements, you could use one of those APIs to push data in, and we are actively working on updating our TechIO library to support higher order elements. With this release, rendering of isosurfaces and slices works just like it does in normal Tecplot 360. You just place an isosurface, place a slice, and we do the subdivision for you. Rendering of curved meshes, so we'll take that higher order mesh and we will do a subdivision to create the curvature, rendering of stream traces, and the beta is currently available on mytecplot.com. So let's talk a little bit about the detail of how Tecplot 360 does this. So this plot on the left, you're seeing a what we call a 27-node hexahedron, and so it has these additional nodes. So traditional elements that Tecplot 360 could post-process only have nodes at the corners, and the higher order elements introduce nodes at, say, edge centers or even face centers. So that's like this node at the center of the face, perhaps cell centers as well. Of course, Tecplot 360 can handle cell-centered data. But with the current Tecplot 360 that's out there, 2022 R1 and previous, we would only pay attention to the corner nodes. And so you would get an isosurface that looks like this one, which is clearly not a good solution. Now, if you take it one step further and say use those natural nodes to subdivide the cell, you're going to get a solution that looks better. And this is, so Tecplot 360 can do this now in our technology preview. ParaView does this, one level of subdivision, but you're still not getting the highly precise solution that you really want out of your high order element simulation. So Tecplot 360, under the guidance of Scott Imlay, has added a way to do what we call a recursive subdivision. So we'll take each one of these subdivided cells and we can subdivide it even more using the basis functions for those higher elements. Scott Imlay, do you want to comment a bit on how we use those basis functions and do this recursive subdivision?
Sure. So we subdivide at each level only those cells that need to be subdivided, or that may contain the isosurface in this case. So you would check the range of the data for the isosurface variable and exclude those that aren't needed, and then you repeat that, subdividing that one. Now, every time you create new, do a new subdivision, you create new nodes, and those new nodes you need to actually use the original basis function for the element, the full element, to calculate the values of the solution at those nodes. So yeah, that's how we do it. And then once you get down to the finest level, it's the subcells are rendered as if they're linear elements, but they're much finer, of course, than the original cells.
Right. Yeah, I think one of the important things to latch onto in what Scott Imlay just said is we actually do a selective subdivision. So we're not subdividing the entire volume grid. We're kind of making an educated guess by looking at the ranges of the data at the nodes to understand which cells to subdivide. And I'll do a live demo later where we show the importance of that technique. But the idea here is it's much like the SCPLT file format where we only load the data required for the plot. This is a similar concept in that we only subdivide the data required for the plot. And what we're showing here on the right is a plot of surface data, and you can see again if you subdivide just at the natural nodes. This is a tri-6 element. You still have a fairly coarse grid. As you increase the levels of subdivision, you get a much nicer curvature for that grid. And again, I'll do a live demo of this. Okay, and in experimentation, a couple of things that we found with the number of levels of subdivision that you do. Of course, more subdivision requires more time, it requires more RAM. And in discussing this with a couple of our launch partners who have collaborated with us on this development, we've come up with a little bit of advice here that, isosurfaces and slices, these are really qualitative plots that you're creating. And you can see looking at the plot on the right here, the difference between 1 versus 3 levels of subdivision can be a little bit hard to pick out. I mean, you can certainly see in this upper left plot at 1 level of subdivision, the isosurface is a bit more chunky in this area versus the 2 and 3 levels of subdivision. You can see on the side of the nacelle here, there's a little bit more detail here in the 3 levels of subdivision that you have in 1 level. But really, it's a qualitative plot, and so we think that for most users, the 1 or 2 levels of subdivision is going to be enough. And just point out here that this is, like I said, this is a technology preview. We haven't built a full user interface for adjusting some of the settings. So this is adjusting the number of levels of subdivision, and a couple other fields here are available in the quick macro panel, and we'll show you how to use that. We'll point out that the team's done a great job with performance here. We see that with this same data set compared to ParaView, we're 20 times faster at 1 level of subdivision. So You can see the data here at one level of subdivision. To create this plot in ParaView took 137 seconds. In Tecplot 360, it took 6.3. And then all the way up to 4 levels of subdivision, we were still 2x faster at 4 levels of subdivision. But you can see with the additional subdivision, because we are creating additional cells at each time we do a subdivision, the amount of RAM does go up and pretty significantly. I wasn't able to do 5 levels of subdivision on the machine that I was running on. It only had 32 gigs of RAM, but at each level of subdivision, you're increasing the number of cells by a factor of 8 because of the way the subdivision works. So it can ramp up pretty quickly there. Okay, but where the high levels of subdivision get to be really important is when you're looking at quantitative plots. In this case, we did a velocity profile. So this is a task in the high lift prediction workshop that recently happened at the AIAA Aviation Show. And it was really interesting to try to do that same workflow using this high order element data. And with one level of subdivision, which is again, one level of subdivision is the default in Tecplot 360 for performance and RAM reasons, but it's also all that's available to you in ParaView. And you can see that with one level of subdivision, this blue line is that velocity profile at one level of subdivision. And you can see how much different and in fact less accurate that is than even at 2 levels of subdivision. You get a lot more accuracy just at 2 levels, which is this light green line that you can see off to the right. And then once you get to 3, 4, and 5 levels of subdivision, they're almost all overlapping one another. So if you're doing line extracts, if you're doing stream traces, the higher levels of subdivision can be very useful and in fact give you a more accurate answer. Okay, so let's talk briefly about these settings that are in the quick macro panel, and I'll also demonstrate these as well. So setting the number of subdivision levels can be done with this first option. Values that are accepted are 1 through 5. The default value is 1. Again, that's designed for performance and RAM reasons for getting that initial view of your data set. Includes sub-element min-max filtering. So this is an interesting one. So again, Scott Imlay pointed out that what we do is we don't subdivide every cell in the data set. So we pick which cells to subdivide. And with higher order elements, which cell to subdivide, we have to make a little bit of a guess. So right now what we're doing is we're utilizing the min and max values at the nodes to determine whether we're going to subdivide that cell or not. Well, with a higher order element, you might have a minima or a maxima within the cell. So in order to account for that, we've also added this min-max scaling factor. The default is 1, so we're effectively using just the values at the nodes. So you can see that what we do is we add a buffer to the minimum and maximum values found on those nodes based on this factor. Value of 1 effectively adds no buffer at all. So in this case, you might have holes in isosurfaces, and I'll demonstrate this as well. If you increase that min-max scaling factor, Tecplot 360 will add a buffer to those nodal values, which will then select more cells in the data set to be subdivided to help plug some of those holes. So pretty important set of settings for using high order element data. And now let's jump into a live demo. So we'll bring Tecplot 360 in place here, and I've already loaded a couple of data sets. So this data set that we're looking at here, this came from the high lift prediction workshop. This is a P2 grid, and we only have grid data here. So with this, I'm going to demonstrate how the number of subdivision levels affects the look of the surface data. So if we zoom in here on the leading edge of the cell, and we'll turn on the grid. A couple of things to note here is we are only displaying the grid at the actual higher order element cell. So while we are doing a subdivision at the natural nodes. We're not showing you that mesh at the natural node, so what you're seeing here is the higher order element cell. With the quick macro panel, again, if you don't have the quick macro panel showing in your user interface, you go to scripting, quick macros, and it'll pop up. So I'll just double click on this. Of course, the dialog popped on my other monitor. And let's just bump this up to 2 levels of subdivision. And you can see we've now done more subdivision, and you get something that looks more highly curved. And we'll bump it up to 3 levels of subdivision. And you can see that it took a little longer there, but looks even more highly curved. And we could go up to 4 and 5, but that is going to take a bit more time. So you can play with that yourself. We zoom out here. Now that subdivision did occur for this entire aircraft, and it affects all items in the plot. So if I were to put in an isosurface here, the isosurface is going to be using 3 levels of subdivision. A slice is going to use 3 levels of subdivision, etc. So just be aware that that affects everything in this frame. If we come over here and look at a volume data set, now this data set is interesting. It has actually linear elements on the surface, but it has higher order elements for the volume cells. So we'll just activate a slice here. And again, even though this other plot is using 3 levels of subdivision, this one is using 1. So this setting, the number of levels of subdivision, is on a per frame basis. It's not global for everything in Tecplot 360. So here, let's turn on the mesh, and if we'll just bump this up to 2 levels of subdivision, and we'll see that mesh get denser because, again, the volume cells that this slice is passing through are getting subdivided in additional time. Okay, turn off the mesh. Let's turn off the slice, and we'll show an isosurface. And again, now this isosurface is being done at 2 levels of subdivision. And we can zoom in a bit, and this is what I was talking about with holes. So we see what look like some holes in the isosurface, and this is because there must be a local minima or a local maxima within this cell, and it's not getting subdivided by our algorithm. So what we want to do is we want to give it a little bit more of a buffer factor. So go from 1, and if we just bump it up to 2, we should see this hole get filled in. So there it goes. So now we're actually subdividing more cells. So the performance or the processing time will increase a little bit, but we're getting a more accurate isosurface. So important couple of settings to know about. And then this setting includes sub-element min-max filtering. This is whether you want to actually use that buffer or not. So we could also just say, no, I don't want to do any filtering. I just need to process every single cell in the data set. This is going to take a longer period of time because we're not able to wholesale throw out cells that violate that min-max scaling factor. So some settings there. Again, this is technology preview, so we're really interested to get people to use it and give us feedback. I realize that it's a pretty limited set of users who are going to be able to use it right now because we can only load the CGNS files. But if there's anything that you saw here today, any questions, Scott Imlay and I are certainly happy to have a conversation with you and see what we can do to help with a high order code that you may be using or you may be writing and that you want to see the results. So with that takes us to the end of the webinar and the demonstration today. I really hope that you do get an opportunity to try 360 2022 R1 and that the higher order elements is interesting to you. Just a note on future work for higher order elements. We are going to be adding support to our TecO library and adding higher order element support to the Tecplot file formats, likely starting with our SCPLT file format. We're looking into adding support for the VTU file format as well, which is common with a number of codes, PyFR being one of them as well. So additional development is going to continue to go into hardware element support. So if you have any questions, please go ahead and type them into the question answer pane, and we'll get to those. Tutorials are always available on our website through tecplot.com/videos. We have a YouTube channel as well that you can check out. We have training available on our website as well. As far as getting a hold of tech support, really the best way is support@tecplot.com if you're in North America. If you're in Europe, Western Asia, support-EU@tecplot.com. And then if you're outside of either of those regions, we do suggest that you contact your local distributor. They're in your time zone. They're going to be able to give you the most rapid response.